Hi, my name is Dr Alikhani. I am Dean and Professor at CTOR Academy, and I'd like to welcome you to another session of CTOR channel. Today, as part of the Mechanotherapy, we continue our discussion on static friction. Last time we end our discussion with what factors cause static friction, why we have friction, why we have resistance against the movement. In general, two factors significantly participate in producing friction. One is the perpendicular forces that applies to the surface between the two objects, and second, the surface property of those two objects. The surface property by itself depends on the morphology of the surface that we will going to discuss, and also adhesion that may appear between the two surfaces sometimes. Let's look at each one of these two factors separately. Let's start with the perpendicular forces to the interface between those two objects. Assume we have a book on the table and I'm trying to apply a force to slide the book on the surface of the table. A resistance appears, and now I'm going to do a simple experiment. I put another book on top of the first book that I have, and I'm trying to apply my force again parallel or tangent to the surface between the book and the table, and I notice something very interesting. As I'm pulling the book, I notice that the resistance or the friction increases. It's more difficult to slide two books over one book. And if I increase the number of the book to 3 to 4, this resistance proportionally increases accordingly. In another word, as you are increasing your perpendicular forces, the amount of the friction goes up. That's one of the factors that contribute to the friction. The second factor, as we discussed, was the surface property of the material. What does that exactly mean? If we're looking at the surface of any material macroscopically, we notice it has a lot of up and down, a lot of hills and valleys that appears at the surface. It's small. Probably we cannot see with our eyes, but they are there. When we are putting two objects on top of each other, these hills and valleys interlock and producing a resistance. If you wanted to move or slide one object over the other, you need to overcome this interlocking, either by breaking them or deforming them, plastic deformation. If you're breaking them, it produces abrasion. So abrasion appears during the sliding of one object over the other object, or plastic deformation. In another word, the morphology of the surface between the two objects is constantly changing when we try to slide one object over the other object. That's one of the factors that can be considered as surface property of a material that contribute to the friction. But that's not the only factors on the surface property that may cause friction. Another factor is that if two materials that are interlocked with each other get too close to each other, sometimes atomic bond temporarily appears between them. An electron from one surface can travel back and forth between the two materials. We call that adhesion. Especially if the two metals are close to each other, this is called adhesion, or another word, cold welding. So the word cold welding that you are hearing when the two metal surface are so close to each other that almost they become like one, even though you did not weld these two surfaces together. This is another source of producing significant friction due to the surface properties. To describe mathematically how the surface property can contribute to friction, we call that coefficient of friction. So the formula of friction is included coefficient of friction of one material times the amount of the perpendicular forces that we apply, property of the surface times amount of the force that we are pressing the two surfaces together. Now, one thing very interesting that has a significant clinical application, and unfortunately a lot of people misunderstood this part. Assume we put a box, this time on the surface of the table, and we apply a force. The force wants to slide the box. A resistance appears. What happens if I change the direction of the box? I did not change the material. I did not change the surface property. I just changed the direction of the box. Would the resistance for a sliding be more or less when I'm applying a force? This is similar to the understanding that if we are changing the direction of the wire, or if I'm changing the surface contact between the wire and bracket, is the static friction can increase or decrease. Interesting enough, you will notice there is no change in the amount of the friction if you did not change the surface property and if you did not change your perpendicular force that push the two surfaces together. So friction is not affected with apparent shape between two surfaces, which requires we define two specific terms. One is apparent contact surface, means some things that we look and we think, oh, these two objects are contacting based on this area. And then one is real contact surface. It means that if we're really macroscopically looking at these two surfaces, in how many areas they contact each other. Now ask yourself, why when we are changing the direction of the box and apparent contact area reduces, why the friction stays the same? If you look at macroscopically, you will notice that even though the contact area apparently reduces, the real contact area stays almost the same. Why? Because the weight of the objects now concentrated in few processes, and the process start to have a plastic deformation, flatten, and in general real contact area actually did not change that much. Therefore friction stays the same. Next time when we get together, we are going to talk about the kinetic friction, and gradually we walk toward the role of friction in orthodontics. I hope you enjoyed this session of CTOR channel. If you have not subscribed to our channel, please go ahead and subscribe, and please don't forget to press the like button. Thank you.